Hello. Today I'll be speaking about running highly scalable tracing, logging, monitoring, and metric systems in production. Just to set the mindset, I work as a manager with the Reliance Jio Financial Innovation Services in India. They sell a phone which is the cheapest in India and the highest used. There are a lot of different levels of economics in India. So the Reliance targets that they make a smartphone available in all sorts of regions in India, in villages and in higher classes, in all different sorts of economies, so that we can make the internet available in India everywhere and in the cheapest rates. So because of the cell phone that they produce, everything which sits inside it also gets the customer traction. I'll be setting up the environment for as a software environment for engineers, as in what is the how engineers can look at this from a distributed systems perspective, and how it's a business problem because of a large scale, and I'll be talking about the numbers as well. So we run few, as I said, there is a phone which sells all over India, and it has different apps, and the main app is called GeoMoney, and under GeoMoney there are different services, there are different apps which runs inside it. There are, let's say, there are many payment systems all over the world that I use. So even GeoMoney has a payment system. If you want to book flights or hotels or bus, or you want to shop online, the retailers and the sellers who want to come online and sell their goods and buy their goods, so that even the farmers can come online, we even have an app for that. So everything inside it is to target that most of the Indian people can come online and do their things from a cheapest smartphone available. So these are few of the things that we run. These are few of the products. Recharges and coupons, as I said, and you can like book your travels, book your hotels, and just get the information about, let's say you're standing in an area and you're standing in front of some monument. You can scan it and you'll get the information about all its historical information and anything that related to that area. So these are few of the screens, and that are like this is the bus booking app. Customer numbers and scale. To set up the environment, so there are different solutions for running large scale products all over the world. There is AWS, there is Google Cloud, and there is Microsoft Azure. So we have our own machines. In India, we have our data centers, and when I say data centers, we have computers, Linux computers sitting, which the engineers would control and would work on and set up the system so that it can be used on the higher levels. So GeoMoney, in terms of the request and the user traction that we get, is initially 177 million users in less than 18 months we were able to acquire. We have 252 million subscribers in our different apps. From September 18 to July 19, we acquired 37 million new customers. At the point in 2015, I think, the Indian government ordered that all the higher currency notes would be demonetized, means they would not be available in the market, and everything from the market will be taken back. So when that currency denomination demonetization happened, everyone has to come online to do any sorts of payment. During that time, 80% of the liquid money floating in the economy was through our apps. 80% of the economy, any Indian, the total population of India. 10 million merchant retailers in 17,000 towns and 4 lakh villages. So we want, our goal is to have everyone available on the internet and do their, as I said, do their retail sells and goods, everything using the phones and using internet. So we have 10 million merchant retailers in 4 lakh villages where internet is very hard to reach and people don't have that level of education where they can understand how to use a phone. Only 19, so to understand why India and China could be obviously because of the population plus because of the economies, they are the largest market to sell any of the online product. Is only 19% of today's app market comes outside from India and China. So if a company, if an online product is selling and it's working in India, it has a huge and like in these economies, in these countries, it is a huge market. So this is like from a business perspective. If you are setting up, if you have engineers and if you are setting up working with them, you have to understand how much of user traction, how much of user hit, how much of user load you're getting at any point of time. Even our financial statements are online that you can read. So just to so what would happen when I say that if we have machines where Linux runs and our engineers work on setting up those machines as app servers, data servers, DB servers, cache servers, everything that you like imagine AWS doing, we do it by our own and we have some internal name for that. So all these user traction and all these user hits, and these are actually the subscribers that I just shared. These are actually the subscribers that use the app daily. But it's not. But there are many who would just click the app or who would just click a screen or do like who would not be a real user for our apps. So there is a huge traction and huge numbers. I'll be sharing in the next slides, and the traffic that we serve in our apps. Just to like this picture is having information about so now we have to set up a distributed systems environment using those machines and the open source solutions that we have available and make all these things like logging, tracing, monitoring and metric system work on our distributed system on such large scale. So what would happen is at the collection point, everything would be like we know that these are our goals, that these let's say if someone has been dedicated to work on these are our goals that they have to set up for all these without any breakage. Now at the transport point, so for logging, I just want to show this. I would be coming back to the screen. I just want to show this so that you get a picture like what the final solution would look like and how the research came to this point that we would be serving using all these open source software solutions that are available. Like on transport, there would be Kafka and Logstash, storage, Cassandra, Elasticsearch. I'm not sure, you might be or might not be aware about all these solutions. I'll be talking about all these in next few slides. Analysis would be like Kibana, Grafana, Prometheus, and alerting, Watcher, HP, Sidescope. I just want to have a picture of this in your minds, and then then I will come back to the slides. So log streaming. Log streaming is, let's say you have a lot, when you have different data centers in different locations of the country or different locations of the world, you might be having one data store, one location where you will stream out everything, and that will the main storage of all the logging that you're doing or streaming that you're doing. So there are different solutions for log streaming or message streaming. You would want to in your apps in a distributed system in different apps. You would be so it can even happen that let's say there is an app, there is a product, and it is how it's built is it has underlying different pipelines, different sub packages. Let's say you just can think of a Java project, and you're creating one product, you're creating some app, and then in that app you have multiple small sub Java packages in Eclipse. So now, and all this is happening, and all these have to connect from the user request till the user serve point. So all these are disconnected but in turn connected, and in a distributed systems environment, these would be lying on different machines in different regions. So streaming is a big problem and like something that you would have to take care of. And there are different solutions in the market, there is Kafka, which has APIs, and like it has APIs in Haskell, it has API in many programming languages. We'll just see that. And then there are this Solace, PubSub, RabbitMQ, Red Hat AMQ, Anypoint MQ, Oracle Tuxedo Message Queue. There are different solutions that are available in the market just for log streaming. We would be mainly focusing on why we chose what we chose. Asynchronous programming. Most of the programming language, like people who have worked with Node.js or people who have worked with Python or even Java or other programming languages, they would be knowing that now everything and mostly all programming languages have asynchronous programming. And I think there is asynchronous programming in distributed systems. Creates an advantage for the people and for the app, for the product, but it also for engineers it creates an issue that they have to handle a lot if they are doing all these things and if they have to work on all these things. So now in asynchronous programming what happens is, let's say if you're like I'm sure you might be knowing that if you're just doing a wget call or a curl, you would not wait for it, you would just go to and the next line is just a printf, you will just go to next printf and like not wait for it. But what would happen in a large scale environment is, if there are different sub packages that are creating one pipeline, you would what would happen, it might happen that let's say there are A, B, C, D. A is calling C and B is calling D. So in any of these, in metric, in spanning, in logging or in monitoring, whenever you go from one to the other, whenever you go from A to C and it's not connected, like A is connected with B and B to C, but if you go from A to C, you do a call to A to C, you lose the context at C. And you don't know, like you're not at all connected, and it's all async, and within that package as well, it's all asynchronous programming that is happening because you want to make everything fast. So this is the base problem and the base nice thing as well in like what we would build. Logging, so logging can be a printf statement, logging can be just a counter statement, and logging can also be let's say how much of minutes or how much of time a DB write took and how much of time a DB fetch took, how much anything that you would want to log. You can also log how much a user, let's say from a user click to the serve point of the user, how much time did this took, how much time did an async call took. You can log anything, and these are just few from the software side of perspective that you would want to log. And there are in different programming languages, most of these are available. Like to suppress logging, you have different environments. I'm sure like everyone works in different environments. You have staging, you have production, you have testing. So in different environments, and when you are the one who are controlling these systems, you are the one who are controlling these distributed systems and creating, there are no APIs. You would want to have, and with such high amount of logging, like let's say if you log every user request with 323 million subscribers and all those numbers, what would happen is you will just fill your machine with a lot of text, and that is not useful, and you waste a lot of money there. So you would want to suppress and have different categories of logging, like these are available in most of the programming languages. They are fatal, error, warning, info, debug and trace. You can set these up, and then you can say that okay, only erroneous things should be in the production environment, and I want to even see the info in a testing environment. So Logstash, now when you have a lot of logging, a lot of log files, everything you are doing a writing, your logs are sitting in a .log file. And Logstash allows you to load a log file, and in log file you would put it in the Logstash, it will index it for you. So in next levels, I'll just show you why we are indexing the log files and why these logs files are so important even from a business perspective. The Logstash do the indexing part for you, and it will index it so that you can do fast retrieval and fast fetching. So we use Logstash for indexing the log files that we have. Then there is Kibana. Kibana is an open source solution. It provides you a dashboard where you can see any of the logs that are running. You might be knowing about CloudWatch logs if you use AWS. So in CloudWatch logs, it's just text which filters per compute. But this is Kibana. Kibana shows you something like that. You can have pictorial representation. You can just on any of these lines, you can put a pointer and count like how many times I'm getting this log. Like let's say if you're using different APIs and any API is timing out. So and you are the one who's talking to the shareholder and the provider of the API that hey, I'm paying it a lot of money, but your API is like timing out and your API is like producing a lot of such logs. So you would want to have track of all these things as well. So Kibana allows you to do that. So there, as I said, there can be different logs. There can be web server logs. So when you set up a distributed environment and distributed systems, you would divide your systems in a DB system, a messaging system, a Linux server, and app server and web server. App server would be where you would run your service, and web server would be where you would run all the HTTP calls or all the internet protocols. And then Linux server logs, database logs you can have, as I said, DB writes and fetch, and then messaging logs when you are streaming, and all those things put in a buffer. In let's say if you are serving in different regions of a country, you would want to like store everything at one place and index and then give to the next level. So you would store it, and then in the buffer you would buffer it and then put to Logstash for parsing and indexing that I just showed. Tracing is let's say if you want to have in tracing, you would want to take from a user perspective of a tracing, you would want to know how much time any call and how much time any operation took from start till end. So you would want to trace anything, you would want to trace a lot of things. You would want to trace, let's say if you want to have, if you just want to have the information of invalid user clicks, like the traffic that you're receiving who just clicking but not completing till the payment or not completing till the subscription, would just see the video and like not subscribing to the channel or like any sorts of those things. You would want to have a trace per user from a business. So like just to give a environment for this, we live as a data on internet. So many of the companies that are working in any of the internet sites and the huge sites that we use, they just they take our data and like advertise, and like from the information that they have from us, they advertise, and that's how they earn. So even this is like the basic mindset that you would want to know the complete activity of your user. So when you want to know the complete activities of the user, you would want to track everything that they are doing, and that tracing can do for you. From an engineer's point of view, you would want to have the information. Let's say if something is not working, something is alarming, you would want to know what operation is like timing out, or what operation is exceeding the amount, the limit that they are not supposed to. There are different solutions for tracing available. I'll just speak about few of them and compare, and then like we'll get an idea of how we why and how we are like working on these and the best possible combination of solutions. So open tracing doesn't specify when a span. Open tracing is an open source solution and has APIs which you can implement, and open tracing doesn't specify when it has problems and it has necessities. It's completely open source, and it's quite, I mean it was released way long back. Open tracing does not specify when a span is sampled, and open tracing makes sampling decisions at the end of the span, not at the beginning. What would happen is, let's say if there is a pipeline which is serving from a user request till the user end. what would happen is all the users might not take the same amount of time for every operation. What would happen is any user, because of their internet availability and bandwidth, they can take any amount of time, but you have to sample in any visualizer, and you have so many customers, you would sample and have a visualization of sampled, so that you get an idea of how all these customers can be visualized on one screen. So that's what sampling is, and so you would want to have the control over sampling, and at the end, not at the end of the span, but at the beginning. Let's say in an asynchronous call, what would happen is from the start, it might happen that you are doing multiple asynchronous calls, but you would want to track from the start till the end. And what open tracing does is it lets you, it loses at any point where you are changing the context, because it feels that at the end, wherever it is ending, is something where in that package where my tracing started. So that's the weak points of open tracing. There is something called as Kibana. It's based on a distributed systems paper called Dapper. And Kibana is very good in terms of how context passing happens. So when you have different packages, A, B, C, D, and A is internally asynchronous, and then A to C, B to D, all these asynchronous calls are happening. At any point when you're switching from one package to the other, you lose the context. You lose the context at that point. Kibana allows you, let's say if you are doing any async call, let's say in Java programming language, whenever you are doing an async call, you lose the context completely. So in Java, it lets you store the context, and I initially worked on all these things when I joined them. Now I don't. So on all these, when at any point when you're losing the context, when you're passing the context, you'll store the context, and you will let it at the other package. You will let it at B, C, D, or anything, and keep the context. So Kibana is very good if you might like have something on working on these tracing. You might want to check out Kibana, and it has a lot of support and libraries. I'll just speak about them as well. Zipkin is the visualizer of tracing. So Kibana allows you to write programs. Kibana allows you to write lines of code, but it doesn't have any visualization. Zipkin is a solution for having a visualization and spans. You can have spans. So trace is from start till the end, and spans is the smallest unit within all this complete trace. Zipkin allows you to have such traces and gives you this kind of description where you can say that okay, this is the service that all these, if you see, are different IPs. So these are the IPs, and this is the service that is running, and combinedly the complete async call took this much of time. So you can create different, you can have different services, and you can have a lot of spans and tracings available. There is something called as Jagger as well. I'll just do a short comparison of Jagger and Zipkin. So Zipkin is OT compatible, that is open tracing compatible. Jagger is open tracing compatible. It has Python, Node, Java, Go, C++, PHP, Ruby support, and Zipkin is available in Python, PHP, and Go. As I said, fixed sampling and dynamic sampling rate is something very important in terms of maths also, which lies in tracing, because when the sampling is getting one picture out of what you have in total. So you would want to have dynamic sampling allows you to have no like you should not control and fix a sample that okay, this particular request I'll just fix at this point, and if it exceeds I'll just not sample it. That's fixed sampling. Dynamic sampling is, let's say if multiple users are doing the same call and are doing the same call but have different time, it will sample in dynamically and give you one picture for that pictorial representations. Jagger is UDP. From the dynamic sampling we can understand that it's UTP because we might lose packets, and Zipkin is HTTP. It runs all on the internet protocol. Monitoring is, we would want to monitor different metrics, like the simplest metrics are CPU utilization, user request, latency. If you have worked with, or if you know AWS, you would be knowing about CloudWatch and CloudWatch metrics. So Prometheus is something which gives you, Prometheus plus Grafana gives you a lot of control over business problems, business solutions, plus engineers, what the engineers would need. So you can have push metrics. You can have push metrics in terms of what Grafana would have. Grafana gives you the visualization and default metrics, like you can have CPU utilization and all those things, the default metrics that anyone would need. But you can't have a control over a user metrics where you would want to have, where you would write a line in PromQL, that's the programming language, you would write a line in the PromQL and then run and push metrics at any point of time and have a visualization in terms of, in the visualizer called as Grafana. So Prometheus has, why Prometheus, if people who have worked with these would be knowing that you would have to use one of these, and people use one of these, but that's not the correct solution. Prometheus does have its own problems. Prometheus does not have logs adaptation, like you cannot feed logs that you are generating, you have to write PromQL programming language, and you don't have long-term storage. Let's say from the time I launched a product till the time I'm running, I want to track all the user traction that happened for me. I cannot do that with Prometheus, it loses all the storage that I have, and no user management. I cannot do the categorization per user, I cannot track a user, it is not per user ID. And likewise there are different Prometheus issues that we have. I'm just getting a reminder that I'm running short of time, so I'm just moving fast. Kafka is something, when I was discussing this talk, I heard that a lot of people would have worked with different APIs. And Kafka is like stateful stream processing engine typically used like in distributed commit log, and the Kafka has, so to scale, there are different steps that when you implement Kafka streaming that you would have to take. In Kafka, this is like the basic diagram that Kafka looks like. There are few different important functions like punctuate and a partition that are present in Kafka. What happens is, like when you are streaming a log, you have to divide, there are like multi-threaded workers that are running, you have to divide your streaming of logs, and then that is called context partition, and all those context partitions sits inside a method called punctuate. That's a library of Kafka. So when you do this implementation and so there are some points that if the duration of the process method is shorter than the punctuate interval. So everything is a process in streaming, everything is a process from one point to the other, you are processing it. So if you have the duration of the process longer than the punctuate, like longer than the division, you will not be able to identify which part of the code it refers to. You will lose the context at that point. So you have to take care of these few things, and punctuate methods are called after process method, and like after this partition, and because we have multiple partitions in rate of input messages compared to punctuate period, if you would increase the rate of messages for many of them, punctuate will not be called after a process method. So we would want that the punctuate call in large scale system would happen as minimum as a number of times as possible, so that to have a system where you have this streaming available and you're parsing and you're streaming the logs without losing the point like what you're exactly streaming. So showing the picture. Yeah, this is the solution that we have running in our systems, like in our distributed systems. We do Kafka plus Logstash, we stream plus we do indexing using Logstash. For storage, we have Cassandra, Elasticsearch, and Yeah, and then for analysis, we do Kibana, Grafana, and Prometheus together. Kibana for the visualization that I just showed, and Grafana and Prometheus. For alerting, people who have worked with these would be knowing that Prometheus also supports alerting, but we use Watcher with HP Sitescope to have alerting available, because you can't have in Prometheus you can't have on any line of code. HP Sitescope allows you to have an alert on any line of code. You can have you can parse the code and say that okay, how many times this is hitting any line of code, and then you can set an alert on that. So this is something that we use and like serve our customers. Thanks. Hope it is useful.